Welcome to How to Make Machines. How to Make Machines is an educational resource for electricity, automation, and programming. In this video, we are going to discuss control power. What is control power? Why is it used? What benefits are derived from the different available control power configurations? Control power is power provided for control devices in a machine. Many machines use 480, 240, or 120 volt power sources to perform work. Work can be spinning motors, illuminating lights, or generating heat. These workloads generally use significantly more power than the devices that control them. A 50 horsepower motor may be powered by three-phase 480 volt electricity, but the devices that turn the motor on or off operate at lower voltages, such as 120 or 24 volts. The primary reason smaller voltages are used in control devices is cost. Higher voltage devices require bigger coils, larger contacts, heavier gauge wiring, more massive builds, literally more plastic, copper, and steel. Lower voltage control components are easier to install. Smaller components can lead to less cost for electrical enclosures and panel builds. Higher voltages require specific safety measures to be taken. Expensive training and safety equipment is required to maintain high voltage devices. Now we will describe a simple control circuit. The first step in creating a control circuit is the control transformer. A control transformer steps voltage down from a machine's main power source to a voltage used by the machine's control devices. Control devices include relays, temperature controllers, limit switches, motor starters, PLCs, and push buttons. Control devices and their arrangement represent the brains of a machine. The control system receives and interprets input. It then analyzes the input to generate an output. This analysis can be as simple as a push button completing a circuit, figuratively answering a yes or no question. The analysis can also come from PLC controller with hundreds or thousands of functions analyzing dozens or hundreds of inputs. It can be as complicated as the task requires. To create the brain, we first have to give it power. As is drawn in the diagram surrounding this text, a control transformer is tapped off of the main power feed to provide lower voltage power to control devices. The above represents a transformer's primary coil connected to two legs of a 480 volt three-phase power supply. With the depicted 4:1 ratio, the secondary side of the transformer will provide 120 volts control power. The transformer can also be represented in this manner. Several different symbols for transformers exist. You will find that most are similar to the two examples used here. In some circuits, you may need to provide 120 volts and 24 volts. To get 24 volts from 120 volts, we must add another transformer. Transforming 120 volts to 24 volts is similar to the 480 volt to 120 volt transformation, but we will only use a single phase and the winding ratio is 5:1. We now have a drawing showing three circuits all using the same source power, but isolated from each other by control transformers. This is the foundation of a machine, the control power circuit. Thank you for watching How to Make Machines.